Okay, so let's look at those limit laws and work going through this example. So we're going to look at evaluating the following limit using the limit laws and justify each step. And so we have the limit as x is approaching -2 of this polynomial, 3x squared minus 2x minus 3. So first thing I can do is I can break this down by the substitution rule, right? That says if I have the limit, we can take this and rewrite it as the limit of the first term. So the limit as x approaches -2 of 3x squared minus the limit as x approaches -2 of 2x minus the limit as x approaches -2 of -3. So this was our subtraction law. Okay, so then there was the rule about the coefficient. So if we had a number in front of that variable or term, which we do, this 3, this 2, we can pull those values outside of the limit and first then take the limit and then multiply by those. So we can pull that 3 out and then multiply it by the limit as x approaches -2 of x squared minus, I pull the 2 in front of the limit 2 times the limit as x approaches -2 of x minus, I'm just going to, and I shouldn't have had this -3 here, right? Because I had the minus out here. I just realized I made a mistake there. So that should be a +3. Okay, so minus the limit as x is approaching -2 of +3. So this was the coefficient rule. Or I think I called it constant. We have that power rule with the x squared. So we could basically look at 3 times the limit as x approaches -2 of just x. Once we find that limit, that power rule says we can then raise it to that power. And then I'm just going to bring down the rest, and then we're just going to go through and we can take the limits based off of those two rules we talked about. And I showed you with the graphs at the beginning of class. Okay, so recall we said if we were looking at the limit as x approaches some number of x, it was just that number that we were approaching. So this first piece, right, we have 3. The limit as x approaches -2 of x is just -2. Just didn't like how that looked. And then we have this -2. So again, we have a limit as x approaches -2 of x. It's x, so we just plug in that value. That's the same thing as what we're approaching of -2 minus, and then remember the limit of a constant was just that constant. That was the horizontal line we were looking at. So -3. So order of operations, simplify. So we have 3 times -2 squared, which is 4. So 3 times 4, -2 times -2, so this is +4 minus 3. So 3 times 4 is 12, 12 plus 4 is 16, 16 minus 3 is 13. I forgot to list, it said to list, so this was your power rule. So I wanted to justify each step. And then those were the basic limit laws. Okay, so direct substitution. So, and this is the way you want to go about it now. Always start with direct substitution. So what this says is we're going to go in wherever we see an x in this function, we're going to replace it with -2. So I'm going to come down here. We have 3. I see an x, so I'm going to just put parentheses for now, and then I'll come back in and plug in that -2. So I have 3, I see an x, so I put parentheses, I square that parentheses -2. I see that x, I'm going to put parentheses -3. So now let's go in wherever we see an x, we're going to go replace it with this -2. Do your order of operations to simplify. Exponents first. In this case, we have -2 quantity squared. So -2 times -2 is +4. So we have 3 times 4. -2 times -2 again is +4. So +4 minus 3. So 12 plus 4 minus 3. 12 plus 4 is 16 minus 3, which is 13. So definitely direct substitution is the way to go. Hopefully it falls out and gives you a number like that. If not, if we get an indeterminate form, we're going to have to sit there and manipulate it, and I'll give you those tricks.